Show that the scalar product of any two 4 vector is invariant under Lorentz transformation. Let us choose any two 4 vectors. So let us take A mu and B mu to be any two 4 vector, and they can be represented by A mu with its 4 components A1, A2, A3 and A4, where A1, A2, A3 are the spatial components and A4 is the time component, with A4 is equal to I times AT. In the same way, the 4 vector B mu, which has 4 components B1, B2, B3 and B4, here B1, B2, B3 are spatial components and B4 is the time component. So the transformation equations connecting S prime frame of reference to S frame of reference, and that is between the two inertial frames for A mu and B mu can be written as A1 prime is equal to A1, A2 prime is equal to A2, A3 prime is equal to gamma into A3 plus I beta A4, A4 prime is equal to gamma into minus I beta A3 plus A4. In the same way, we can write it for B mu also. B1 prime is equal to B1, B2 prime is equal to B2, B3 prime is equal to gamma into B3 plus I beta B4, B4 prime is equal to gamma into minus I beta B3 plus B4. Here, gamma is equal to 1 by root of 1 minus beta square, and gamma square is equal to 1 divided by 1 minus beta square. So, what are we asked to prove? We are asked to prove the scalar product of any two vectors are invariant. Now, let us compute the scalar product of the 4 vectors A mu and B mu. So, which can be written as A1 B1 plus A2 B2 plus A3 B3 plus A4 B4, where A4 B4 can be written in terms of I AT into I BT, which corresponds to minus AT BT. So, the scalar product which we need to prove invariant under Lorentz transformation is A mu prime into B mu prime is equal to A mu into B mu. So, A mu prime and B mu prime can be written as A1 prime B1 prime plus A2 prime B2 prime plus A3 prime B3 prime plus A4 prime B4 prime. So, in place of A1 prime, we are replacing it with A1 B1 plus A2 B2, and we are writing the value for A3 prime, B3 prime and A4 prime and B4 prime. So the first component A1 B1 and the second component A2 B2 remains unchanged. The third component can be simplified as gamma square into A3 B3 plus I beta A4 B3 plus I beta B3 A4 plus I square A4 B4, where this plus I square is replaced by minus 1. The similar way we can write the fourth component also, or the fourth part. So it simply rearranges to A1 B1 plus A2 B2. The gamma square is common in third term and fourth term, so it is taken out. So we can club A3 B3 plus I square B square A3 B3 as A3 B3. Within that we will have 1 minus beta square. In the same way we will have for A4 and B4. So the remaining terms gets cancelled. So we are left with A1 B1 plus A2 B2 plus gamma square into 1 minus beta square into A3 B3 plus A4 B4. We know gamma square is equal to 1 divided by 1 minus beta square. So these two get cancelled. So we get A1 B1 plus A2 B2 plus A3 B3 plus A4 B4, which is simply A mu into B mu. So we have proved A mu prime into B mu prime is equal to A mu B mu. Thus, the scalar product of any two 4 vector is invariant under Lorentz transformation.